In today's video, we will discuss permutation and combination, for which first concept is factorial. What is factorial? It is just the continued product of the first n natural numbers. It represents the product of the first n natural numbers written as n factorial. This is the symbol of factorial. Here it will be n, n minus 1, n minus 2 up to 3 into 2 into 1. Let's learn it with an example. Suppose we have factorial 5. It will be written as continued product of the first 5 natural numbers. That is 5 into 4 into 3 into 2 into 1. Similarly, 10 factorial can be written as the product of the first 10 natural numbers. 10 into 9 into 8, 7, 6, 5, 4, 3, 2 up to 1. It can also be written as 10 into 9 into 8 into 7 into 6 into factorial 5, because we know that 5 into 4 into 3 into 2 into 1 is factorial 5. Let's take another example. Solve 10 factorial upon 7 factorial into 3 factorial. This can be solved as 10 into 9 into 8 into 7 factorial divided by 7 factorial. 3 factorial can be opened as 3 into 2 into 1. This 7 factorial gets cancelled with 7 factorial. We are left with 10 into 9 into 8 upon 3 into 2 into 1, which gives us 10 into 9 into 8 upon 6 is equal to 120. Now we will be introduced to the topic permutation. We have permutation and combination. We need to know the keywords for these two. Keyword for permutation is arrangement. You need to remember permutation is related with arrangement. How do we define it? A permutation is an ordered collection of some or all objects of a given set. It is represented by NPR, or it is also represented by P in bracket N and R. What do N and R represent? N represents the total number of objects that are given to us, and R represents the number of objects that we need to arrange. So permutations of n objects taken R at a time is given by n factorial divided by n minus R factorial. Example, evaluate 7p5. We know the formula of NPR is factorial n upon factorial n minus R. So this can be written as 7p5 is equal to p bracket 75 is equal to 7 factorial divided by 7 minus 5 factorial. We solve it. What do we get? 7 into 6 into 5 into 4 into 3 into 2 into 1 divided by 2 into 1. When we solve, we get 2520. Next example. It says, how many 4-digit numbers can be formed by using the digits 1 to 9 if repetition of digits is not allowed? Now see, how many digits we have in total? We have 1 to 9. So we have 9 digits. Number of possible 4-digit numbers is equal to the number of permutations of 9 different digits taken 4 at a time. So required 4-digit number will be given by 9p4 is equal to, then again we will apply the same formula. Here n is 9 and R is 4. So we will apply the formula of NPR, and when we apply the formula we solve and we get the answer 3024. Or we can do it by box method. Now we have 9 digits available with us, and how many places we have? 4 places, because we have to form a 4-digit number. So units place can be filled in how many ways? 9 ways. Why? Because we can put any of the 9 digits at the units place. Tens place can be filled in 8 ways, because 1 digit we have already used at the units place. Similarly, hundreds place can be filled in 7 ways, as we have already used 2 digits here. And last place can be filled in 6 ways. Therefore, total number of ways in which this 4-digit number can be formed is 6 into 7 into 8 into 9 is equal to 3024. Let's begin with the concept of combinations. Keyword for combinations is selection. Always remember, selection is associated with combinations. So combination is an unordered collection of some or all the objects of a set. It is represented by NCR or C in bracket N and R. The formula is N factorial divided by R factorial into N minus R factorial. So what does it represent? Combination represents the number of different selections of R things taken from N things. Most important is order does not matter. How? Let's see an example. Suppose we have 4 letters A, B, C and D. We have to select 2 at a time. Therefore, it can have AB, AC, AD, BD or CD. In this case, AB and BA are same combinations. It will be counted as 1. It will not be counted as 2. Whereas in permutations, these two are different, but in combinations, these two are same. Example. In how many ways can a team of 3 boys and 3 girls can be selected from 5 boys and 4 girls? As you can see in this example, that we only need to select the boys and girls. Order in which we select does not matter. Therefore, we will have to apply combinations. Let's see how we do it. Number of boys, 5. Number of boys that we need to select, 3. So this can be done in how many ways? It can be done in 5C3 ways. Similarly, number of girls is 4. We need to select 3 girls. So the number of ways in which we can select 3 girls out of 4 girls is 4C3. Therefore, the total number of ways to select 3 boys and 3 girls will be equal to 5C3 into 4C3, which will give you 40.